Hello, I'm here to talk to you about box fill calculations. So you're ready to put some conductors in a box and some outlets, and you need to determine what size box you need for the job. So box fill calculations are a way to tell you how to do that, and there's a code. The NEC has specific guidelines on what you are allowed to put inside and how much you're allowed to put inside. If the box is overfilled, it can get overheated and then you can have some problems. So when you're ready to look at what size box you need, one of the things you have to say to yourself is, what am I putting in this box? So here are some examples of what you would be putting into the box. You would be putting in grounded conductors, ungrounded conductors, some clamps, and a device. The device could be a switch, an outlet, a duplex outlet. So you have to consider everything you're putting into the box and how much space it takes up. So the amount of space something takes up is its volume. And that table 314.16b is the volume allowance per conductor. Most common conductors for residential are 14 and 12. So I put a partial list up here for you. Size 14 uses 2 cubic inches of space. Size 12, 2.25 cubic inches of space, and size 10 uses 2.50 cubic inches of space. So, for example, if I had 2 size 12 conductors, I would have to allow for 2.25 plus another 2.25 or 4.50 cubic inches of space just for the 2 conductors. I also put up an example. I drew a little box here for you. In this particular box, I'm going to use size 14 conductor. So I already know size 14 uses 2.00 cubic inches of space. I also have 3 Romexes, an in and 2 outs. This particular box, I put in an outlet. And I have a couple of internal clamps. We do not count the external clamps, so the only thing that we need to worry about is everything inside the box. So in order to determine how much space, the minimum space I need in the box, I'm going to add up all of the volume of all of the pieces that go inside the box. So first thing I'm going to look at are where the 3 Romexes are. And where this one comes in, you have your ground, your hot, and your neutral. Ground, hot, neutral, ground, hot, neutral. And you can pretty much tell by the colors. I know it's hard to see the white on the whiteboard, but the green is the ground. Ground is a little different because we consider all of the grounds as just one. The conductors, each one is counted as 1. And any kind of device, every device counts as 2. Internal clamps count as 1. So if there's more than 1 internal clamp, we're just going to count it 1 time. So let's take a look at the example I put up here. I know we have conductors inside here, so I'm going to look at how many wires are with these conductors. I'm not counting the ground. I have 1, 2, 3, 4, 5, 6. So there are 6 of them here. The grounds, even though there are 3 grounds, we count the ground just once. If there were different size grounds, you would just choose the largest ground, whichever one takes up the most space. So in this case, they're all 14, so I'm going to count the ground once. We also have an outlet. Any type of device gets counted twice. We have 1 outlet, so we're going to count it 2 times. So that gets counted twice. And it doesn't matter how many internal clamps there are. So if this has 2 internal clamps, we're still just counting it 1 time. So that's 1. So we end up with 6, 7, 8, 9, 10 altogether. So we have 10 items to account for. We're using size 14 conductor. Based on the table, it is 2 cubic inches. So we do 10 times 2, or 20 cubic inches. So when choosing my box, I need to make sure I have a box big enough that can hold the 20 cubic inches. I'll have more examples for you later. Bye.